Hello everyone. Today's problem is smallest distinct window. Difficulty of the problem is medium. In this problem, we have given the string, and our task is to find the length length of the smallest window that contains all the characters of the given string at least once. Means we have given the string, and in which there will be the characters. Some will be repeated, some will be unique. So we have to find the substring which will have all the characters which are in the given in the string. So here in this example we can see a b c d, four characters are there. So we have to find the substring of the minimum length which will have all these four characters at least once or more than one time. So we can see here the substring will be of length 4, dbca, which is here dbca. In the same case here in this substring there are two this unique characters which are a and b. So we have to find smallest substring. So here it is ab, you can see here, and here it is geek. Here 7 are the unique, so geeksfor or forgeeks can be the unique substring. Now coming to the expected complexity, it is given that n square and the space is big of 1. And now topic we can see sliding window, arrays, hash and strings. So it is basic. So now coming to the approach. Now let's talk about approach first. So, what was the given example? aabcbc. A B C B C D B C A. The very brute force approach which comes to our mind is the n square approach. Means making the generating the each substring and checking whether it containing all the characters or not. First of all, we have to check whether how many unique characters we have. So in start we can take the map data structure, and we will count all the characters in the uh, string which are uniquely present. So we can do by the map. We will do it later. Now we'll focus on uh, how to generate the strings by n square approach by the making each generating each substring. Now considering this, uh, first will this will generate the first we will calculate all the unique characters. So here it will be 4. Now we will generate this. Here only uh, one character, here only two characters, here only three characters, here four characters. So we found the substring and the size is 5. So we mention it. Now we break here. Now we go to now the next iteration. We go like this, like this, like this, like this. So and same case we can find we can generate all the substring and check one by one. Same case we will generate like this, db, dbc, da, dbca, which contains all the four characters and which has the minimum length of 4. So we will return the 4 here. So it is the brute force approach which takes the time complexity of n square and the space complexity of n for storing the elements. Now see the code. Now you can see here we have taken the map for uh, counting the unique elements. And here we are just taking what are the size of the map, what is the size of the map, which tells us about unique characters, and we are we are clearing the map for the future uses which will be used or which will be used during the iteration. It is for storing the length. Here the n square approach, where we have used two loops which will generate all substrings. Here in the map which we cleared, we are putting each entry, and each time we are checking with the size that we taken from the that size. Size means original elements, how many original elements. Each time we are checking and updating length. Once we get the length, we are just breaking and going for the next iteration, and each time we are clearing the map for handling all the test cases. So this is the working code, and this will working fine, but after some test cases it will give the TLE. So this is not the optimal approach, but this is the working brute force. Let me run for you. Yes, this is working very fine. Now coming to the, now we have to optimize this code. So in the topics tag also we have given, this is the this is of the sliding window approach, and this is a very typical template, that smallest distinct window. Whenever the window comes, it is absolutely problem of the sliding window. So we can solve it by the sliding window approach. Now make it like this, and let's make the code visible. Okay, now understand the sliding window approach. Now taking the same example for the this approach, a a b c b c d b c a. Now here we will calculate the unique characters by map as we did in the brute force, so that thing will be same here. So here unique characters will be 4. Okay, so now as the sliding window says, there will be two pointers, one will be the left and one will be the right. So we will we will we will traverse the R until we find the size of the temp, means size of the map in which we are storing or preserving the elements by right are equal to the unique elements. So now let's start the traversing. First let's make the map first. Okay, this is map. Now we have the R here, so we are adding R. Okay, R goes here, so we are adding here, it happens to. Okay, moving R forward, it comes here, means B comes here, then R goes forward, we make the entry of C. After that R goes forward, R goes forward, we make the entry, it becomes 2. R goes forward, we make the entry, it becomes 2. As the R becomes, R goes to forward, goes forward here. Now we have all the elements here, in which means when we are traversing through R, we collected all the elements in the map here itself. So we collected all 4 elements here, and original there will be 4 elements unique, there will be 4 unique elements will be there. Now what to do, we are comparing that we are comparing that while our condition is true that size equal to map size. We will do this until this condition is true. What we do is we will just take the length of minimum. We'll take the minimum and right minus left plus 1 each time, and same time we are removing the element from the map also using the left. Now we are traverse. Now let's see here. Here you are left, so we will increment the left by 1. Now how will it happen? Let's see. Now left goes here. Now left goes here. We remove 1 here, so 2 is removed. Now left goes here. We remove b of 1 here. Okay, after that r goes here. Left goes here. Left goes here. We remove the c. We remove the c once. Then it's lagging something. Okay, then one by one it goes like this, and all the entries become ones 1 1, and after that once we get, means we have to just remove the elements from the uh, map until the size is same as the map size. Means once the size becomes less or the unequal, then it will stop. And what will happen here, let's see this condition directly. Let's see this condition directly. It will follow the size and give the element here itself. So I can show you the code, so it will be very helpful for you. So same thing is happening here. Let's say we are storing this right in the temp. Okay, and then we are checking this size. While this temp size is equal to the size, this is calculated by, but this is the size of unique elements. Then each time we are taking the length because we want minimum, and we are removing the left from left, and if it is 1, then we are directly erasing it or decrementing it. This is the logical stuff. And this, then we are incrementing the left, and this is we are doing until this is true. This is when this get false, then the right plus plus, and we starts traversing again. So its complexity is something around big of n. And space complexity, because we are using map here for storing and retrieving, hashing is using here, so we can use big of n also because n elements are there. Now let's see the code. same approach to count unique elements. Okay, then these are the two pointers which will be used to traverse. Now right is only valid until this less than string's length. Now storing element in map, then when we gets the string, we can say substring of required of all elements. So until and unless this condition is true, this all things will run, and after all pointer incremented, and here we are returning the minimum alien length. Now run the code. Yes, it's running absolutely fine. Now submit the code. So all test cases are passed. Thanks for watching.